In today's lesson, we're going to be introducing a topic that is central both to the study of probability and that will come up all over the place when we start talking more about statistics, and that's the idea of a random variable. So up until now, we've been thinking about experiments and statistical experiments as having a sample space that has sort of arbitrary outcomes in it, right? So we think about drawing a card from a deck of cards, or about flipping a certain number, or flipping a sequence of heads and tails. But oftentimes, we're going to want to be able to summarize this information more effectively rather than thinking about sort of the sample space as it exists in the real world. And random variables are one method for us to do this. So, in general, the two objectives that we have today are to both understand the concept of a random variable, and again, we want to do this intuitively as well as mathematically, as well as to differentiate both discrete and continuous random variables. So we saw when we were doing descriptive statistics that differentiating discrete and continuous variables were important. We're going to have a similar differentiation here. So to begin, I'll pull back two examples that we saw slightly earlier when we were talking about probability, and that's the idea of the weather forecast, or say rolling dice, playing games, right? And when we were talking about the weather forecast, we indicated that the sample space of possibilities is quite large, right? And it's sort of this strange thing to think about, the set of all possible weather conditions. Instead of that, we might think about trying to summarize just the parts of that random experiment that we care about, right? So instead of me saying what's going to be the weather for this week, maybe what I'm interested in is what are the average temperatures throughout the day for this week, or how many days this week do I expect there to be rain, right? And so in this way, we can sort of take this experiment of looking at the weather over the next week and summarize it numerically using different things that we might care about. You know, if we're thinking about playing a game of chance, instead of thinking about the sequence of rolls on a dice, for instance, we might think about how many times did a certain outcome occur, right? Or we might summarize it by the sum of all of the different rolls of the dice. And so again, here we're thinking about trying to take the sample space, turn it into something that we actually might care about, and then use that to discuss probabilities as well. And so this sort of motivates the need for random variables. With random variables, we're trying to make our lives easier than dealing with the abstract sample space. And so often we want to summarize these results numerically. And a random variable is just a mathematical function that takes in the input from our experiment and maps that to some real number, right? So we could take the input of our experiment as being the sequence of heads and tails on 10 flips of the coin, and a random variable might be how many of those times were there heads. Random variables take real values and they're dictated by chance, right? So these are mathematical objects that will be associated to some real number, and the value that it takes on is going to be random. And so that's why we call these things random variables, right? If you think about dealing with just straight up algebra and you write down that x is going to be your variable representing something, if the possible values that takes on are random, call that a random variable. You can think about sort of endless numbers of examples of this, and we'll see them throughout the course, but just to sort of start here, the number of twos, if you roll a dice 5 times, is going to be a random variable because we take 5 rolls of the dice and we summarize it with a number. The sum of 2 dice, right? Instead of the combination, we're summarizing that with a number. The number of days of rain, say this week. The yield of a batch of chemicals, so on, right? Anything that you're going to summarize an experiment using a numerical value is going to be a random variable. Typically, we're going to denote random variables by the capital letter and then realizations of that with the lowercase letter. So we saw when we were just talking about data sets that we used lowercase x to denote those. When we introduce random variables, we're going to use capital values, right? And so the capital value x will take on the lowercase value x. Sometimes, and this will be rare in this course, but in case it comes up, it's worth pointing out, we want to make explicit the fact that a random variable is a function. And so if omega is the outcome of our experiment, so maybe omega is, heads, heads, tails, tails, heads, right? Then we can write x of omega is going to be our random variable. It's a function of the experiment, right? And so if that's counting up the heads, then x of omega in that case would be 3. Now, intuitively, a random variable is just a mathematical variable whose outcome depends on chance. It's more convenient to think about random variables that summarize the experiments that we're running rather than the experiments themselves. Generally, in this class going forward, we're only going to be working with random variables, right? And you can think about this as sort of a mathematical convenience of sorts, right? It becomes very cumbersome to think about the full results of an experiment, especially because normally with our experiment, we only care about some component of it, right? We don't actually care about, say, the health status of every individual associated with which individual that was. If we're running a medical clinical trial, we care about what proportion of them got better, what proportion of them had bad side effects, how much did it improve their outcomes by, these types of things, right? And so this sort of allows us to focus in on what parts we care about, ask questions of that, and that's sort of why they're so central to the study of probability and statistics. Now, I want to sort of bring up an example here. And so, on the screen, we have a picture of the library here, right? And we could think about running, say, different experiments within the library, right? So maybe what I get you to do is I get you to sit in the library and I wait until the first person goes to check out library books, right? And that's going to be your experiment, is what library books is this person taking out, right? And then I could ask you what random variables are associated with this experiment, right? Because of course, the experiment or the outcome space for this experiment is going to be sort of any combination of books that are in the library could be taken out by the next person. And that's going to be a really hard sample space to work with. And so how might you summarize this? And I'd invite you to actually try to do this. I'll run through some different possible examples here, but you could pause the video and try to work this out for yourself. But really, the question is going to come down to, what do we care about? Right, so one way we might think about this is, how many different books is the person taking out? Right, and that'd be a random variable because it counts up the number of books. Or we might think about, how many total pages are there between all of the books? We could think about, what's the weight that they've taken out from the book? We could think about, how long is the longest book, or how long is the shortest book? What is the year of publication of these books? How old is the student who's taking out the books, right? Any of these quantities are going to be a way of mapping our random experiment to real numbers. And so they're all going to be random variables. And each of them sort of allows us to summarize just one key aspect that we do care about in order to ask more specific questions about that. I'm sure you could come up with sort of many more, right? How many of the books taken out have a red cover? This type of thing. And I'd encourage you to think through them and sort of really convince yourself that this concept of a random variable is going to be a very useful concept for us. Now, we have discrete and continuous data. We're also going to have discrete and continuous random variables. So if it can only take on a countable number of values, and so normally we're going to have this be the integers, then we say it's discrete. Right? So if you're going to count up how many books did an individual take out, that's going to be discrete because it's going to be 0, 1, 2, and so on. Some examples that might come up: the number of siblings that an individual has, if you're measuring age in years, if you're going to get a percentage grade in a course and there's no sort of fractional measurements, these are all going to be discrete measurements. If a random variable takes on an uncountable number of values, we say that it's continuous. If it can be anything in a range, then it's continuous. So if you were weighing the books, right, it can be sort of any value in that range, and so we would say it's a continuous random variable. Now, one point to make: in the real world, most things are not actually going to be continuous, but it's useful to abstract this way, right? So with the weight, of course, it's going to depend on what scale you have. And in some sense, your scale is only going to be able to measure out a countable number of values. And so you could say that, well, that's discrete. But in practice, there's going to be so many values and they're going to be so close together that it's going to make more sense to think about that as actually being continuous, right? So just as a point there. Types of things, if we do height, if we do weights, if we take time measurements, we're normally going to be thinking about these as continuous random variables. So that's the idea of random variables. They're a mathematically useful way of summarizing the results of an experiment so that we can sort of make more use out of them. They're going to be mathematical functions which summarize the experiments by mapping them to numbers directly. Intuitively, we're thinking about random variables as depending on chance, and we can differentiate between discrete and continuous random variables. In the next lesson, we're going to continue our investigation into random variables and the probabilities surrounding them, and I hope to see you all there.